Okay, so at the beginning of the classes, I like to kind of start out with what you guys see in front of me, which is like our to-do list. This doesn't get posted up onto Blackboard at all because it's just kind of like if we were in an in-person class, this would just be like written on the board and we will like check it off as we go. My pencil's not on. So what was I gonna say? The first thing I want to talk about is WebAssign and practice homework 1. There is, oh my gosh, hold on, my pen is not on. Sorry if you hear some chewing. I gave Duke a pig ear so he would be distracted. Okay, so there's nothing on WebAssign currently, but tomorrow, depending on, how do you spell tomorrow? We'll say Tom. A practice homework is going to be posted just on WebAssign. There's no Blackboard for that. That's just kind of get you guys used to playing around with like how I enter something, how do I play with my homework? So I got a lot of emails for you guys who are like, I don't have access to the homework. There's no homework right now. It's fine. So the homework will be assigned. And also, actually, I don't know how many people are even in our WebAssign class. So that'll still give you time to figure out how to join our class and see if you want the textbook and stuff. And then I also wanted to talk about, oopsies, 1 second, how to upload written homework. So each homework, remember, has 2 parts. Part A is on WebAssign, so you can remember that there's an A. And then the second part is like 4 to 5 questions, similar to or the same as what's on WebAssign. I just want to see your work and make sure that you guys are working through problems correctly. Like WebAssign, you get, oh, how many? Like unlimited attempts, but like you could just be plugging in every number in the world and not doing it correctly. I want to be making sure you guys are doing it right and then give you feedback before test day arises, and then you find out that you're actually not working through these problems correctly. So homework part B, there's no practice for this, right? So this is submitted through WebAssign, not a WebAssign, Blackboard. Oh my God. Blackboard. Please submit this with a PDF. So like, I don't like JPEGs. I know you can take pictures on your iPhone. Sometimes if you leave the live thing on your iPhone, it'll send me a movie of your thing instead, and then I can't look at that at all. And that's like weird. I just really don't know how to deal with that. And Blackboard like won't let me look at it. So how do you submit something on like a PDF? Like how can I take a picture of something on my phone if I don't have like a printer that scans? My printer doesn't scan. So there's this awesome app called Adobe. Hold on, I need to find it on my phone. I think it's either Adobe. Oh my God. We're fine. I think it's either called just Adobe Scan, and you can take a picture and it'll put everything into a PDF. So that's another thing. If you have multiple homework pages, I just want one PDF with multiple pages. It just makes my grading like go so much faster if I don't have to download 10 JPEGs or HMEIs, whatever sometimes like iPhones show up as. It would just be better if they were all PDFs. Again, this is just a preference, but I think there will be incentive on our first homework that you guys do turn in me, maybe some extra points on your first exam if you successfully upload a PDF, one PDF, not multiple PDFs. The Adobe Scan thing will put them all in one PDF. You just like hit next. It's really easy to use. I use it on my written homeworks. There's also more apps. You don't have to use this one, but I just really like this one. Okay. So you're gonna have a practice homework. Practice homework means I'm not grading it at all. It's just you guys are getting comfortable, and it's just on WebAssign. There's no other one out there. Okay, cool. Here's a picture of Duke napping yesterday. He's really cute. Okay, so we started a point 2 last time. I think we only got through the first page, and then we're also going to move on to A3 if we have a chance. I hope that we do. So let's go start our notes. So let's remember last time we talked about just kind of like the number line and how it works. That line is not straight. Talked about A is less than B, A is greater than B, and a set. We also talked about these closed brackets versus open brackets. Closed brackets, we're going to include whatever the bracket is associated with. If it's on the left, like it is with the A, I'm going to include A. If it's on the right with that B, I'm going to include B. Think of it like a brick. It's solid. The ends are exact. They're A and B. Open brackets, also known as parentheses, are softer. There's no definite, this is the last point. All we just know it's going to be all the numbers up to that one value, but not including it. Think of it like a cloud. I don't really know when the exact end is, but I know where about it is. So a few examples that we can run through: the set containing all numbers between 1 and 2 and including 1 and 2. So if you guys, I think you guys should be able to type this answer. If anyone has any ideas or what they think it can be, I would love to hear. Where is it? Okay. Right, Griffin's right. So it's going to be bracket 1, comma 2, bracket. Another way we can write this is using inequalities. So this is what we would call interval notation. I need to learn how to spell. Is that how you spell notation? Yeah, right? If I can represent something like that. I can also represent it, since this isn't very clear, as -1 less than or equal to x less than or equal to 2 for any x, right? X can just be any of those numbers in between them. So think of those like closed brackets as I'm going to have that equal to. It can equal where the bracket is involved. Does that make sense? Oh, that's not supposed to be a negative. Oopsies. Sorry, I don't know why I put -1. So if I have a bracket, I could possibly equal 1 or 2. If I don't, I can't. Okay, great. Does that make sense? Are we kind of okay with that? Okay, thank you. Oh my gosh, Jada, you don't need to call me ma'am. Okay, cool. So the set containing all numbers greater than 1. Real quick, I want to talk about, remember how we talked about how I can write some sets like this using the fancy brackets? That's when I have a finite amount of things, right? I have 4 things, 1, 2, 3, and 6 right up here. And that's when I can write a set like that. But when we're talking about all of these numbers, there's infinite amount of numbers that are greater than 1. I'm not going to list out every single one of them. That's ridiculous. So that's why we use interval notation, or I need to figure out, I call it like answer with inequalities. I think some people might call it set notation, but I could be wrong. So the set containing all numbers greater than -1. That's where I wrote the -1 because I was getting carried away. So what's one way that we can write this? This one's a little tricky because we're only given one number. Oh my gosh, how did you write that infinity? That's really cool. So yeah, it's going to be -1 infinity. Griffin, since you've answered both my questions, can I also write it like infinity to -1? No, why not? Jaden also says no, that is correct. Yeah, why is this wrong? Not wrong. Oh, it is wrong. Yeah, the lesser number goes first, right? It's kind of like saying, yeah, right. It's weird to write it like that. You want to read left to right, like kind of what we were talking about last class, that there's a natural ordering of the real numbers, right? Negative numbers. Negative 100 and 1, negative 100 is still smaller since it's negative, so it's to the left. And that's how we like to read left to right. Just how the number line works, that's how I want my intervals to show up. And that's not fun. So I'm gonna erase this. I think we talk about this a little later. Oh, it's also right there. Spoiler alert. Okay, cool. And what's another, someone also wrote in the chat. Abby wrote, so this is interval notation. I really need to figure out what the other one is called. I don't think it really has a phrase. -1 less than x. So you can also say x greater than -1, right? Do you guys agree that these three are all the same? Right. Oh my God. Right, so I can flip these inequalities around. I'm just kind of saying something is greater than or something is less than, the same thing, right? It's just who am I talking about first? Okay, great. How are we feeling about all of these? These few examples. Let me see if I need to make sure I read my notes and now I'm forgetting about them because I want to see if I can bring up. Yes. Yeah. So I said no, we always write intervals in increasing order, right? So -to infinity. Did I type this wrong? Hold on. Oh, that's supposed to be negative infinity right there. So what I meant to say is -to negative infinity doesn't make sense, right? It's like saying that -2 is somehow smaller than negative infinity, which is like not a thing. What if can I ever have like a closed bracket within an infinity at all? Is this possible? Something like this? No, right? Infinity isn't a number that I can hold. It's just kind of a concept of an idea. Like the horizon, you can never touch the horizon, or it's not flat, we're not debating this. Right, nothing can equal infinity. And a limit can. You can approach infinity, that's why we have limits to talk about, so that we have some way to like talk about infinity. We can't ever attain infinity. So you guys ever equal infinity to something, I'll cry. So don't do that. Okay. So that's interval notation. Let's talk about more about sets. So if you tell me that something equals infinity. So if I want to talk about what sets what they have in common, I'm going to be talking about the intersection. Okay, let's spell this word right. It's definition, intersection. There we go. So the intersection of sets, let's call them A and B. We usually like to use capital letters for sets. We denote that. So the way that I would write that is A, and then this thing is called a cap. It's not an N. But if you want to think about, well, I guess union and intersection have the same amount of N's. Anyways, it's the set that contains of all elements in A and B, right? So if you think about like your normal Venn diagram, it's that middle bit. It's in A and it's in B. The union, oopsies. What is it? Union of sets A and B is denoted a cup B. So we call that a cup. It's not a U, it's a cup. So cap and cup. And it's the set that consists of all elements that are in A or B. So again, if you're thinking about the diagram, both circles included together, that is the union, including the intersection. Well, sometimes we don't have any sets, anything in an intersection. If A is all positive numbers and B is all negative numbers that don't include 0, the intersection, there's nothing. So there's something called the empty set. And it's denoted a 0 with a line drawn through it. So I usually draw mine like that. It's different than a phi or a phi, if you are familiar with any of those. So just a 0 with a line through it, right? So it's the set containing no elements, right? So usually, remember we talked about sets having like the little squiggles. If you write it like this, that's the set containing the empty set. That's different than the empty set. So those are two different things. Oh my God, okay. So when you need to tell me that the answer is the empty set, please do not write the set containing the empty set. That's different. It's technically incorrect, so I don't want you guys to think that. All right, so let's work through this fun example. We're given that S is 1 through 5, all of those whole numbers, integers, and T is 4, 5, 6, 7, and B is 6, 7, and 8. So we're first asked S intersected with T, right? That's what 1 is saying. So I have S, I can draw S in like a fun little circle over here. Oopsies. It's gonna have 1, 2, 3, 4, and 5, and then T also has 4 and 5, but it also has 6 and 7. So what do we think the intersection is between S and T? 4 and 5. I don't know. So should I just write 4, 5? I would look next to the P. Yeah, there you guys go. Abby's got it. Oops. I want squiggly brackets, remember? That's a set. Right, I just have 2 values. I don't have all numbers between 4 and 5, not including 4 and 5. That's what that means. That's totally different. That includes all the numbers between 4 and 5 that aren't 4 and 5. I just want the set that contains 4 and 5. Do you all see the difference between the parentheses versus the squiggly brackets? Okay, great. Now what about the union of S and T? So remember, union, I can think of and, or sorry, not and, or, right? It's an A or B, it just has to be in at least one of them. Oh my gosh, you guys, I'm too young to be called ma'am. Please don't call me ma'am. Or you do, it's more respectable. I actually don't care anymore. Careful, Jaden, you only included 2 numbers. Yeah, CJ's got it. No, you're fine. I know sometimes we'll write notation like after you kind of assumed a pattern, like 1, 2, comma, dot, 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 7. Sometimes we write that in our notes. That's fine. Don't give me that on an exam. Right, so 1, 2, I'm just showing that I'm moving up 1 and then I'll stop at 7. But it's good practice to write them all out. Right, when you write just 1 and 7, I don't know that you mean all of them. 3, 4, 5, 6, 7. And CJ, can you quickly type how you got that answer? Or you can explain your reasoning a little bit?
Can I just say it?
Yeah, I'm totally fine with that.
Well, I just since we're using union, I just use every number that was consistent within S and T.
Right. So I wouldn't include 8, right?
No, because 8 is not in S or T.
Yeah, exactly. Good job. That's awesome. That was a great answer. Perfect. All right. Any questions so far? Am I going too fast? Okay. So now we have S intersected with V. So if I were to draw V inside of my diagram, let's choose a cute color. I like this pink. So V has 6 and 7, but it also has 8. That's V. But do S and V have any numbers in common at all? Right? No. Careful, Abby, you wrote squiggly brackets. So it is the empty set, right? There's nothing in there. It's okay. I just want you guys to understand the difference because it is actually kind of confusing that there's a difference, and I just want to know that you guys know what you're saying. Right, so it's our empty set. We can actually say, since the intersection of these two is the empty set, what we kind of say, you can even kind of see these, and when I drew them, that they are disjoint. They're two different. They don't even touch. So it's not a number, it's a symbol. So it's not the 0, it's the empty set. Right, it's just how we use a symbol to represent like cup and cap for intersection and union. It's just a symbol that we use to represent it. I'm glad you guys are asking all these questions. Will we ever use the bracket for empty set or not? No, not in this class. And I don't, unless you're, is anyone studying mathematics or statistics? Okay, Alyssa, that's perfectly fine. I'm so happy that you said that. Brackets are, so these squiggly brackets I use when we have like just numbers, right? I have 1, 2, 3, and 4. I could have smiley face, square, circle, rectangle. I just have like a few things. I use interval notation like we did up here when I have lots of things. I can't list out every number between -1 and infinity. That's too many brackets. That's too much. So these squiggly brackets kind of denote what's in my set. The empty set, that's already a set. So I don't need the squiggly brackets to it because this symbol kind of has already, right? It's already defined to be a set. So I don't need to define the set again. Does that make sense? And if you're a little confused now, I think working on homeworks and more problems, I think we'll be able to hunker it down. All right. So that was intersections and unions with sets, which was really fun and, in my opinion, a little bit easier because I can see all the elements, right? Remember, elements are members of the set. They're part of the exclusive club. When I'm working with intervals, though, and finding their union and intersection, This is where it kind of gets a little bit more rigorous. So I have A is 0 to 5 non-inclusive, 3 to 7 including 3, and 6 to infinity inclusive, right? So what I like to do for these problems is use the number line. When I started grad school, I was 2 years out of college. I didn't remember how to study. I didn't know what I was doing. I was very much a freshman. How do I take notes? How do I study? I don't know what I'm doing. And I'd be working on homework with my friends in class, and they would just be like, draw a picture. I can see, you just need to draw a picture. You need to visualize it. And sometimes that's hard to do in mathematics when you don't know what to draw a picture. But now it's a number line. I can draw a line. Do I have space up here? No. I can draw my line. And I can, not really using 0 at all, so I can put 0 down here. Let's put 1, 3, 5, 6, and 7, and then just kind of whatever, it goes on, right? Using the number line is drawing a picture. It really, really helps. And it definitely helps because union and intersections, brackets versus open brackets versus closed brackets is really, really important. All right, so let's work with A union B. So A, someone give me a color for A. Red, I knew you guys were gonna say that. Red like an apple, right? So I also really love colors. I'm going to draw an open bracket at 1 and an open bracket at 5. So that's A right there. For B, I know you guys are all going to tell me to put a blue. So I'll just go here and put a blue. And then I'm going to square bracket at 3. I missed a little bit. And open bracket at 7. Someone give me let's do C while we're at it. What's a good color for C? Clear's not a color. Ronald said pink. I love pink. If I can decorate my whole house with millennial pink, I would. I live with a man. Okay. So we're going to have 6. And I'm actually not going to draw an endpoint because I can't, right? It's an infinity. So stop being funny in the chat. Let's go back to writing in green. A union B. So, right, its union is or, right? Would you just draw an arrow? Maybe like something like this. You're fine. How can you have open and closed brackets? I can include one end of my interval and not the other. I can include 3 and not 7. Yeah, drawing these lines is also a really good way. I'm on to demonstrate kind of what you're saying. So drawing a line kind of gets that overlap is also really helpful to see. Let's put, where did I put red? There it is. So like under here. Where'd pink go? All right, how's that picture? Right now I've drawn my picture. I have made the most useful tool that I could for this problem. Okay, careful, CJ. Remember the number line, there's infinite amounts of numbers between all of these numbers. So you're just kind of working with what are called integers. They're whole numbers. So A union B. I'm going to include everything that's in A and in B. They're coming together. Holy matrimony. They are union together. So I'm going to smush them together. So let's see. Jaden says 3 to 5. I think you might be thinking of intersection. And Jaden says 1 to 7. Jaden, can you explain your answer to me? Okay. Everyone can stop guessing answers. Oh, no, you're fine, Abby. We're on 1 right now. Union. Right. So it starts at 1, right? A starts at 1. So the smallest number is going to be almost 1, right? We're not including 1. So that's why we're going to have open bracket 1. And then remember, it's including everything that's an A or B. Well, A only goes up to 5, but B keeps going, right? B doesn't stop at 5. It keeps going all the way up to almost 7. When we write intervals, I just want to talk about the first number and the last number, because those rounded brackets or parentheses or bracket is going to tell me it's an interval. Squiggly bracket is going to tell me if it's a few sets of numbers. So, oopsies. 1,7 tells me that's an interval. So that's including every number between 1 and 7, not including 7. Remember we talked about the number line being dense. So it can include 1.5, 1.7 repeating. I can't write all those numbers when I have something like this. This just is 1 and 7. I also writing 1, 3, 7, having more than 2 numbers there. I don't know what that means. That's not, well, yeah, 1 and 3, like that's kind of giving me a little bit that I don't know that notation. Intervals are just going to involve 2 numbers. The first number where you're going to start and the last number where you end. And then what type of bracket, open or close, tells me if I include that number or not. All right. When I talk about squiggly brackets up here, I'm only going to talk about squiggly brackets. So when I'm talking about these set brackets, let's call them set brackets. That means I'm just including those 2 things, not every number between 4 and 5. Does that make a little bit more sense? No. You will not. So if you see set brackets, you're only going to use set brackets or the empty set. If you see intervals, so open brackets, close brackets, aka just a regular bracket, that's what I like to think the regular bracket is, and a parentheses, that's all you're going to work with. And I think if you're still confused, we're going to work through these. It might help. And if you're still confused, well, that's what homework is for, and office hours and coming to me. All right. So now let's do the intersection, because I think someone already has said it. Thank you, Jaden. Your solution and explanation were amazing. So number 2, A intersected with B. So everything that's in A and everything that's in B. Ooh. So Abby and Mary, Jaden was super, super close. Abby and Mary got it right. Mary Catherine, sorry. Mary Catherine, do you go by Mary or Mary? Or I need to ask you guys what you guys go by.
Mary Catherine.
Okay, my grandmother's name Mary Catherine, but she only goes by Catherine. She's Mary Catherine Black, actually. So that's really funny. I'm gonna tell her about you. That's why I asked. Okay, cool. So do either one of you explain why you included 3?
Well, 3 was included in the original with B, just saying it in the equation, so you would just keep it included.
Okay. So it's also, yeah, so it's included in B, and 3 is a number between 1 and 5. So that's another reason it's included, right? So I can see that 3, right? We talked about the number line being, I keep saying the word dense, but it's that red line crosses over B. It's right there. So both of them have 3, and that's why I'm going to include 3. Where is my green that I like to use? There it is. So we're gonna have a bracket. Oops, that's a 5. Got really excited. Bracket 3, and then 5 was the last one, right? 5, yeah. Why don't I include 5? Right, it is an open bracket for 5. Why? Can anyone tell me that part? Close, Abby. 5 is included in B, right? Because it's every number in between. Oh my God. What color did I use for blue? It's every, B is, it's like really going ham on that pick here. It's only in B, right? That open bracket in A, this is telling me that 5 is not included in it. So remember, intersection it has to be in both sets. So since it's not an A, it's automatically an open bracket. Right, just what Griffin said, it's only in B. Okay, cool. Is that the last thing in here? Oh no, okay, cool. So now we have A union C. Remember, C is every number between 6 and infinity. A is 1 and 5. Abby says 1 and infinity. Griffin says 1, 5 union 6 infinity. So sometimes we can't write it all in one cute interval, right? We can see right here between 5 and 6, A and C doesn't exist. So Griffin wrote 1, 1, 5 union 6, infinity. 1 to infinity includes this tiny little interval that A and B do not live in. A and C, excuse me, are not involved in. So actually, I'm just kind of writing what A is and writing what C is and leaving union there. Sometimes I can't combine them into one interval, right? What does that say about the intersection of those two sets? So number 4, A intersects C. Is that for every equation like this? What do you mean, CJ, in every equation like this?
Like where we would just write out whether it's like, you know how we wrote out 1.
Oh yeah, so I mean, yeah, right. You can write A union B like 1, 5 union 3, 7, but that's still kind of confusing. So I guess what I really should have said is like simplify each set, right? So like some things can't be reduced down, like number 3. I can't put all of that in one interval because it's the union of 2 intervals. Where when I put 2 intervals together that overlapped, I can make one of them, like I see in 1 and 2. So this will only happen with union, where I'm gonna write two, I might have to write two intervals union together. I mean, that's a way to write the question. So I think you guys are feeling a little confused on how writing this works. So like A intersect B, right? A is 1 intersect 6 infinity, but like I can't reduce this down at all. I can't put it into one thing. So unions are the only ones where you're going to be able to write two intervals. Intersections, either there's an intersection or what? What's my other option? Right, the zero with a line through it, the empty set, right? Call it the empty set. It's not because there's an infinity, it's because look at the picture we drew. You can zoom in on it, I think, right? A is in red and C is in pink. A is over here. Oh my God. And then C just continues on. There's this area right here in between them. They don't, so they're never overlapping. There's no overlap. Think of intersection as two intervals overlapping or two sets overlapping. There's no overlap, so I'm going to draw the empty set. So infinity actually doesn't come to play. But that is a good question. Okay. Let me check on Duke real quick, make sure you didn't like throw up. So 1 second. What are you doing? Are you okay? Okay. We're back and we're fine. Okay. Any questions about these so far? Thumbs up, thumbs sideways, thumbs down about unions and intersections and stuff. Thumbs up. And please be as honest with thumbs up, thumbs down, and thumbs sideways. Can you explain overlap? So intersection, I'll do this really quick. Intersection is something that's an A and B. And is really important. So it has to be in both of them. So if we're talking about sets that look like this, the intersection is this middle bit. These are intersections. When I'm talking about intervals, it's the overlap. All right. So A and B intersected right there. But A and C don't overlap at all. So there's nothing that's an A and C. Okay. Just drinking some water. Okay, cool. Great. Awesome. So now we're going to talk about a really cool function. And that function is called the absolute value. Right? It's denoted these two big lines. So if you're typing it, it's the you do like shift and then the key that's above return. So the backslash, and then if you hit shift backslash, it'll give you that bar. Just call them bars usually. And it's the distance from A to the origin, right? So if A is a positive number or just 0, we consider 0 a positive number in this house. That's just going to spit out A again. If A is a negative number, oops. So if it's strictly less than 0, then I'm going to negate it again, right? A negative number times a negative, we talked about this last class, gives me a positive. So That's why that's negative A right there. So basically, absolute value of A spits out A without any negative signs. It just kind of strips away my negative sign. Okay, so there's some fun properties. W/O, this is shorthand for without, and I write in shorthand. If you guys ever have any questions, please yell at me. I will not write in shorthand. Properties. So if absolute value of A is going to spit out A without any negative, what's absolute value of A always going to be greater than or equal to? 0, right? It's going to always be a positive number or 0. If I have the absolute value of A times B, I don't always have to put that little dot right there. I can just put the letters next to it. I know that's multiplication. I can figure out what the absolute value of A is times the absolute value of B, and those will be equal. Well, if it's true for multiplication, then it's true for division for the most part. What do we think about number 4? What is the absolute value of negative A? What is that going to equal? What if A is a negative number? Always going to think of that. Ooh, it's going to be the absolute value of A. Because think about it, because I didn't tell you that A is only a positive number, right? A could be like -3. So absolute value of 3 is the same as the absolute value of -3, right? You can think about it as if I use property 2 on 4. So think of that negative as a -1, right? So that would equal absolute value of -1 times A. Oh my gosh, somebody wants to go on a walk. Then I would have absolute value of -1 times the absolute value of A. I'm using property 2 here. Absolute value of -1 is just 1. 1 times anything is just itself. So that's how I get absolute value of A. All right. Really great effort, guys. So I only talked about negatives and multiplication and division. How do we think it's not going to work with addition, right? So the absolute value of A stops behaving nicely when addition and subtraction are involved. There's supposed to be like a really big space here, and I'm kind of sad there isn't. Messed up my notes. So who believes that A, absolute value of A plus B, and absolute value of A plus absolute value of B are the same? Duke, come here. Come. They're not the same, right? So if I had like -3 plus 5, well, that's going to be absolute value of what, 2, which is just 2. But absolute value of 3 plus the absolute value of 5 will give me 3 plus 5, which is 8. And I don't know about you, but 2 is not 8. It doesn't work. So addition, including subtraction, doesn't play nicely with absolute value. You have actually something like this, absolute value less than or equal to A plus B. That's actually called the triangle inequality, and it is a big thing about theoretical mathematics, but that is not anything that you guys have to worry about. So I'm going to erase it before I confuse you. All right, cool. So why am I introducing absolute value in the middle of this section where we're talking about other stuff? It's because we can define the distance between A and B as the absolute value of A minus B. And we denote that with a D, comma, parentheses A, comma, B. And that's going to equal absolute value of A minus B. So I'm going to put in two numbers, and then I'm going to subtract one from the other, and I take the absolute value of it. So that's going to tell me how far away they are from each other, right? So this is just kind of a function notation. D is not a number I'm multiplying by. I'm using D because we like to name things by what I'm doing distance. So I'm gonna call it D. That's what my function's name is. And we'll get on to function notation later in class if this is kind of confusing. So what should D of -3, 5 equal to? If I'm using this fun little formula up here. Ooh, Griffin, you kind of skipped ahead. How did you get 8? How did we get 8? Yeah, so I'm first going to start with plugging it in. So I have absolute value of A, so the first number, so -3 minus my second number, which is 5. And then think of absolute value as kind of like a parentheses. If you remember PEMDAS, or some people did like BODMAS, I don't know, order of operations. I'm going to do 3 minus 5, so that's going to be absolute value of -8. And that's going to be 8. And the reason, oops, not 0. There we go, an 8. The reason that we bring up distance is because we can represent it on the number line. So if I have 0 here, 1, 2, 3, -3, 1, 2, 3, 4, 5. This distance right here represents the length of this interval. I'm measuring an interval. Is that cool? And that's 8. All right. So you guys try 2 and let me know what you get. And someone can walk me through it. Let me leave this up. There we go. Okay, I got a lot of 14s. Ronald, Mr. Anderson, how did you get 14? Can typey type? Or anyone can explain me how they got 14. Perfect. Interesting. So, but it's, ooh. I wrote the problem wrong. There's supposed to be a negative, but it is 14 because I realized I was wrong. So I have -5 minus 9. And that's going to be what, -14? And that's 14. Perfect. What about if I had -5? Oh my God, my 5s looks like S's, and I'm sorry. -9. What then? Then I have 4, right? Beautiful, Ronald. So when Ronald wrote his answers in the chat, he put -9 in a parentheses. That's a really good way of making sure that you don't forget about a negative, you don't drop something along the way. Remember what we talked about last class, that negative gets distributed. So I'm gonna have -5. Oh my gosh, what is happening? +9, and that's where I get a 4 from. Perfect. Great job, everybody. Alrighty. How do we feel about absolute value? Because this is the end of 8.2. Thumbs up, thumbs sideways, or thumbs down? Jared says, meh. Okay. Great. So that's all for A2. Done. Actually, don't write that because that's going to mess up my notes. So we have like 15 minutes more left of class. We're going to, oh my gosh, what am I doing? pop over and talk about integer exponents. Kind of flip a switch. You'll notice in A that the chapters sometimes are not that related, but it's just kind of like a refresher, hopefully. So can someone quickly tell me what is an integer? Griffin says any number. No, that's fine. I like the participation. Jaden says real number. You are a whole number. Fancy name for a real number. So a fun thing that I did, we had to like make these fun little booklets. So you have these numbers, right? So we kind of only care about real numbers. So we're not even gonna talk about imaginary numbers. So we have real numbers. And that includes things like 1.7 repeating, 3/4, 1, and stuff like that. Then I have smaller, a more select number called rational numbers. And that only includes things that I can represent in ratios. Well, I can represent any whole number in a ratio, just 7/1, and so on. That's a rational number. Integers are what Jared said. They are whole numbers. Like 1, 2, well, that's a Z. I meant to say 7. And a 7, right? Numbers like that, whole numbers. And then you have even smaller, something smaller called the naturals, which are positive numbers not including 0. Okay? That's just a quick explainer of numbers. So when we're talking about integers, I'm talking about whole numbers. And we also have fun symbols for all of these. So I would write the real numbers with a double bar R. Have you guys ever seen that notation before? Yeah, so double bar R, that's a real number. Rationals is a Q with a line through it. Integers are Z, double bar Z, and the naturals are double bar N, the only one that makes sense. Well, reals also make sense. So these are just groups of numbers. So when I talk about integers, or I ever say like N is an element of Z, that's what that notation says right there. It's a whole number. So that's just a quick explanation of that. So right now we're just working with integer exponents. And first we're going to work about integer exponents that are positive, right? So A is just any number. Right now I'm just going to want to work with numbers that are greater than 0 or 0. That's when I say that A greater than or equal to 0. And N is an element of double bar Z, meaning it is an integer. And N is a positive number. Technically you get B, N. No, we're not doing that. Okay. So when I write A to the N, that means A times A times A. How many times do you think I'm going to multiply A by itself? N times, right? So when I'm saying A to the N, A is what I would call my base. And N would be, I would call my exponent, or what's another word I could use here? What else would you guys would call that N? A power, right? Right, to the power of N. I'm gonna make sure that makes sense. Okay, cool. Right, so if I'm doing 4 to the third, I would write it 4 times 4 times 4, which is 16 times 4, like doing 2 at a time, which is then 64. I think we're all familiar with that. Quick survey. do we think that in example 2 and example 3 are going to have the same solution? Yes or no for the same solution? No. You all would be correct. Right? So remember, right here, what's my base in 2? Correct, Jaden, it's -2. So my base here, -2, where my power is 4. So I'm gonna have -2, -2, -2, -2, and then I can kind of group these together. Oh my goodness. So -2 times -2, those negatives cancel out. So I'm gonna get 4, and then this one's gonna be 4, and I get 16. Beautiful. What about in 3? What's my base here? Duke? What's my base in problem 3? Just 2. Why is it not -2? Why is it not -2? Right, there's no parentheses. There's nothing attaching the negative to the 2. So if you want to think about it, the power is only attached to the 2. This is why parentheses are so important. So my power is still 4, but my base is only 2. So that 4 isn't involved. Yeah, exactly, Abby. It's just like saying -1 times 2 to the 4th. Absolutely right. That means I can write it as like -1 or just a negative times 2 times 2 times 2 times 2, which is going to be -1 times 16, -16. Oh my God, supportive. Right? So that's the difference between those two. So if you mean to tell me this and you give me this, I'm going to have to take some points off because that's wrong. Okay. So we only talked about up here if n was positive. What happens when n is negative? What does that mean? What if the exponent is negative? It's a fraction. Well, what if a is already a fraction? Oh, it's an integer. Is it an integer? No, it's just a positive number. No. So first we say that a does not equal 0. I'll get to that in a second. Then a to the negative n. Everyone's saying fractions, but how would I write? I'm going to put a bar there for a fraction. Who wants to tell me what a to the negative n is going to be equal to if I made it into a fraction? So it's going to be 1 over, it's kind of hard to type this, 1 over a to the n. So n becomes positive, and I move it down to the denominator. Think about this over 1. So the way that I learn this, if I have like a to the n, it's over 1. If I think of this as like a house, right? I have 2 stories. Numerator, denominator. Numerators is second floor, denominator is the bottom floor. A has a negative exponent. It's not happy. It does not like being upstairs. Heat rises. It's way too hot. We live in South Carolina. So I can put a in the denominator where it's happy and it's fine down there. It's still good. N is still an integer. A is not an integer. A is just any number. So it's a real number. So, right. So a negative exponent correlates with what's called a reciprocal, right? You might not think of a to the negative n as a fraction. Remember reciprocals, we just kind of flip it. But I'm talking about this exponent is going to change to a positive number. right? So Griffin kind of wrote it the right way. When you talk about powers, you want to use the little boop, boop. Okay, great. What time is it? We have 5 minutes. Do we have time to get through these? Okay, since we're still new to Socrative, I'm going to stop here. And then we'll talk about properties of exponents next time. Example. Are you asking for an example, Ronald? Okay, yeah. So, like if I had, I'm gonna erase my house. I don't want to erase my house. I'm gonna erase my house. No. So if I had, right, like 2 to the negative 3, that's just gonna equal 1 over 2 to the third. It's just 1 over what, 8? Something like that. I could also have x to the negative 2, and that would be 1 over x squared. That make sense? Why can't a be 0 in this definition up here? Can anyone tell me why it cannot equal 0? Right, 0 can't be in the denominator at all. I can't divide by 0. If you have an iPhone, you can ask Siri why you cannot divide by 0, and it's pretty funny. I have a Google phone, and I miss out on those luxuries. So you can't divide by 0, and that's why you can't divide by 0. So that's why. Oopsies. Let's do can't divide by 0. Okay. How are you feeling with integer exponents so far? We haven't done too much. Cool. Thank you, Abby. All right, coolio. So we have 3 minutes left in class, right? I don't want to end class early. Oh no, I'm right. Okay. So it's Socrative time. So when you open up Socrative Student on your phone, or if you go to Socrative Student login on your computer, oh my God, thanks, Abby. Our room is my last name in all caps. You're welcome for having a nice last name to spell. And then it's 943, no spaces, right? Tell me how you felt about today. Tell me what we learned today. And then your teacher question of the day. What is -3 cubed equal to? There we go. So -3 cubed. That is your teacher question of the day. Once you all finish that, you are free to go. If you have any questions, I'll hang out for a little bit. I think are you talking about the first one? I think like how it goes for the day. The first question should be how you felt about today. So like A is I got it. B is I somewhat got it. C is like meh, down like that. I'm pretty sure. Could be wrong. Let me try. I have a Socrative student account. They also just updated their thing. Don't forget to put your last name, comma, first name. If you didn't, it's fine because these are just practices. Yeah, so A is totally got it. B is pretty well. C is not very well. And D is not at all. All the other answers should be, third question is what did you learn today? And then 3 is please answer the teacher's question. I do not have office hours figured out yet, Hannah Ann. I will send you guys out an email and update you guys in class. I'm still waiting to figure out when my MTC hours are before I schedule office hours. Because if they don't schedule me for those hours, I would like to be in office hours for those hours, and I don't want to like overbook myself and put myself into 2 places yet. Thank you guys.
Miss Black,
Yeah.
for the question, I accidentally like put the teacher question answer. Is that gonna like be a problem or?
No, it's fine. I understand when you guys get too excited and put the teacher question.
Alrighty, cool. Bye.
Bye, have a nice day. Oh my gosh, we don't have class on Monday. Didn't know that. Thank you for reminding me.
Are we gonna next class? Are we gonna go over the problems with like the properties of exponent, like the ones that we didn't finish?
Oh yeah, we're not done. Yeah,
Okay, cool.
we're gonna keep going.
All right, bet.
Just because we didn't finish in class doesn't mean we just don't get to learn it. It'll be here on Tuesday. Okay, I'm gonna stop recording.